All right, we're going to start Unit 6 here under chemical kinetics. This first lecture video is going to focus on the rates of chemical reactions. So let's first define what kinetics is. Essentially, kinetics is the study of how fast a chemical process occurs. The rate of a chemical reaction can be expressed by using these following two equations, which take the time here to kind of go over a little bit. So with these equations, the first one here, the rate of a chemical reaction is based on the negative change in the reactant concentration. Now these brackets that you see here, those brackets indicate molarity as a concentration. And of course, molarity is the number of moles per liter of solution. And so whenever you see brackets like that, we're talking about molarity concentrations. So again, you can determine the rate of a reaction in terms of the change in concentration of the reactants over the change in time. We can also see this in perspective of the products being formed. The rate at which the products are formed is based on the change in concentration of the products over the change in time. So either way, either perspective, we can look at the reactants change in concentration, and it's negative because we're losing concentration of the reactants, whereas the products is positive because we're gaining more product over time. Now we can graphically represent this. That's what we're going to do here in these two boxes. We're going to take first the perspective of the reactant concentration. Now, since the reactant concentration should diminish in time because we're using up the reactants, we should get a line or curve that looks like this, essentially. All right, when we fix this curve just a little bit, it should be more like this. Okay, and so what we see by this curve is that, first of all, the slope of this is equal to the rate. So what this tells us is that initially the reaction is really quick. So up here, we're starting the reaction out. It's really fast, right? And why is it so fast? Because we have a lot of reactant to begin with that can react with each other to form product. But over time, the reaction rate begins to slow down. So down here, it's really slow. Now, why is it so slow? Well, that's again because of the reactant concentration. Here at the end of the reaction has very little bit of concentration, and so we have a slower reaction that's occurring at that point. So that's what the slope looks like for reactant concentration versus time, which you need to be able to draw and be familiar with. All right? So now let's turn our attention to the products and what that's going to look like. Well, with the products, we should get a slope that is just kind of the opposite. Again, the line represents the slope, which is the rate of the reaction. So what we're finding here is initially the rate at which we make product is fast. All right? We're making a lot of product really quickly. But then as time goes on, the amount of product that's formed begins to slow down. And that's because we're running out of reactant. And when we run out of reactant, obviously we can't make more product. And so the amount of rate of product development begins to slow down. All right? So this is what it looks like with product concentration versus time. So again, the rate of this is just the concentration of the products, and that's the change in over the change in time. Right? And the slope is positive because we're producing more product. All right. So these are two important graphs. Make sure you understand that kinetics deals with the topic of how fast things go. Understand that what the rate is and how to calculate the rate using those two equations, and be able to graph the concentration of reactant versus time, as well as the product concentration versus time. Alright, so that's it for this lecture video.